And welcome everybody to the Art of Science TV, where we connect, converge and converse on the latest in scientific research and how it affects our everyday lives. In this time of the great convergence, where fields and information are cross-pollinating, constantly cross-pollinating, we'll be reporting on the cutting edge information on the impact of COVID-19, but further taking science into its impact on our everyday lives. And please welcome today's panelist, Dr. Tim Boyle, strengthening society, as always, by putting science to work. He's also the Director of Innovation and Commercialisation at ANSTO. Hello, Tim.
Hi, Christina, and hello everyone out there in the audience.
So, Tim, let's go straight into COVID this week. It doesn't seem to be going away. What might the reality be of how long it's going to hang around for, and how's it actually going to affect our day-to-day?
Yes, and now 2.5 years and maybe a billion cases, infections into this pandemic, and COVID has clearly turned into a permanent part of our lives that we just need to learn to live with. Most experts knew that this was going to happen from very, very early on. For almost everyone was going to get infected at some time. And all the interventions that came at the start of the pandemic, such as lockdowns and social distancing and mask wearing, those measures were more to slow down the rate of infection, to not overwhelm the hospital system, rather than to try and eliminate and eradicate the virus, which is what most of us thought. And the reality is, you're not just likely to get COVID, you're most likely going to get it again and again and again and again. But how that affects us and what that looks like will differ greatly between us, because we're all unique individuals. We all have genetic differences and other cofactors that sort of play a part in how our immune systems work and our immune response and how we respond to challenges and pathogens presented by the virus. Now, the current thinking is that the typical COVID infection is likely to get less dangerous as population immunity builds and broadens through their exposure to the virus. We've had the virus and recovered, and vaccinations. So collectively, we're going to build up immunity and tolerance to the virus through exposure over time. However, considering our current baseline in that, and the rate of people are dying is still, 1 to 2 every 1,000 cases, which is pretty high in perspective. That at least one person in our lives that we know will probably die from COVID-19. That's less dangerous is still a pretty bad outcome, and it could be terrible. The consequences could be very high, and we currently just don't have enough information about reinfection and what that looks like. Although the circumstantial evidence does seem to suggest that reinfection is much, much more mild than a primary infection, especially if you've been vaccinated. The best thing to do is to be alert to the fact that you may get the virus at any time, and you may be reinfected. Having the virus once doesn't mean you're not going to get it again. There are many variants of the virus circulating now, and they're all different. And the immune response that you have to one virus subvariant may be very different to the immune response you have to a different subvariant, even though they are related to some extent. But we need to take protective measures as required and a sensible approach. However, on a day-to-day basis, we need to learn how to live with the virus rather than live in fear and hide from the virus, because it's not going to go anywhere.
Tim, that's so, I read this week that Hugh Jackman has got the virus again. And will it be that will we keep testing, do you think? Will we keep finding out whether it's COVID? Will more tests come out to say, maybe I can self-test at home and go, I've got the flu, I've got COVID, I've got something else, influenza A, influenza B doesn't show up, it must just be a common cold. Do you think we'll get to the point where we will be testing all those things, or will COVID testing go away and we'll just kind of go out into the community going, well, I've either got a flu or a COVID or a cold, or I won't know? What's your gut feel on that? Because I know there's no research clearly on that, but what's your gut feel on that?
Yeah, I think it's one of those cases where prior to the pandemic, we would get a cold or we'd get sick, and we would either soldier on and think, oh, I'm tough, and we'll go to work and probably make all our colleagues sick. Or if we didn't recover after a couple of weeks, we'd go to the doctor, and then they'll do a swab test and tell us that either there was something more concerning or it was the flu. And that was how we managed infection and the common cold type symptoms and viruses of that nature. But since the pandemic, regular testing has become quite common. So if you go and have a COVID test at a pathology or a drive-through clinic now, a PCR test, they'll also take that swab and they'll test you for influenza, they'll test you for RSV, rhinovirus. So you can pretty much work out what you have. And this is new. And then couple that with the availability of RAT tests, rapid antigen testing, point of care testing at home. It changes the dynamic. So I don't think that's going to go anywhere either. And I think what most likely will happen is that the bigger PCR testing centers will disappear over time. Some of them are starting to close down now. The big vaccination centers will close. You can get vaccines pretty much at your local GP or pharmacy now. And the requirement for vaccines is dwindling as herd immunity increases. And I was listening to a great podcast with Joe Allen, who is instrumental policymaker in the US around technology transfer innovation policy, was indicating that there's now an oversupply of vaccines in the US, and that the requirement for them is decreasing. And a lot of these rapid manufacturing centers, the investment in manufacturing for messenger RNA facilities is now being mothballed because the demand isn't there anymore. I think we'll continue to see this sort of trend, but the diagnosis point will move. We'll have more availability of testing at home for all these different diseases. And then what you do with that information, whether you seek further medical advice, you isolate and wait till you get better, they're things where society hasn't really come up with what the expectation, what the standard will be. I suspect that people will be much more conservative about going to work when they are sick now. People who have post-viral lingering coughs from COVID or the flu, and that's a lot of people now, they get nervous and embarrassed when they cough, because people automatically assume that they're infectious and can make everyone sick and question, why are you here? But they're likely that they've passed the infection. They've just got inflammation in the throat and it hasn't resolved and cleared. No, they may cough for months. But should they return to work or not? I think society is still adjusting to these changes, and what the societal norm looks like is not obvious to, or the protocols around that societal norm haven't been established yet. So it's a space still to watch.
And I think if everybody sticks to the protocols of hand washing and, that high hygiene that we've become used to over the last few years, I think that will alleviate. And as you say, you're not game enough to cough or sneeze in public in case anybody thinks that you are spreading disease. And also the permission to stay home if we're sick, which people have always had but haven't actually taken it up. If we go back to COVID as well, the loss of smell has actually seemed like I'm meeting more and more people who have lost their sense of smell. Funnily enough for me, because I had paired smell with taste, but they haven't actually lost their sense of taste. But a lot of people, and maybe it's because more people have had it, and that's why I've met more people that have lost that sense of smell. But what causes the loss of smell? What do we know about this?
Yeah, so researchers are finally making some headway in understanding how COVID causes loss of smell. And it's leading to some potential new treatments to tackle this condition. And some of the obvious ones, the front runners, are steroidal treatments and blood plasma, which is another interesting we use our own biochemistry and parts of our own body in a new way to solve a disease and to repair ourselves. But smell disruption, once was the telltale sign that you had a COVID infection. However, it seems becoming less common as the virus is evolving. And this is supported by a study that was published last month that surveyed just a fraction over 600,000 recovered COVID patients in the US. And it found that compared with those who have been infected with the original virus, people who had contracted the Alpha variant, which was the first variant of concern, the Alpha variant was the UK variant, there were 50% as likely to have chemosensory disruption, so the sense of smell disrupted. So in that first mutation, the impact of the sense of smell dropped by half. And the probability fell to 44% for the Delta variant, which is the Indian variant, and then 17% for Omicron and its subvariants, which are the current variants of concern, that are spreading, or the variants of note that are spreading through the community. But the news isn't all that good. It seems that we're getting the probability of having loss of smell is decreasing, but it's not like all good. A significant proportion of people infected early in the pandemic still experience chemosensory effects and their loss of smell. And the study published late last year, it followed 100 people who had mild cases of COVID-19 and 100 people who repeatedly tested negative. So it was a controlled trial. More than a year after their infections, nearly half of those who had COVID-19 still had problems with their smell. So out of the 200 people, half of them got COVID, half those again, 25%, 50 people still had problems with their smell. In the control group, surprisingly, those that didn't get COVID-19, 10% of that group lost some of their smell, but for non-COVID related reasons. Furthermore, 7% of those who have been infected still had total smell loss at the end of the year. And given that, you try and stack this up, it's predicted there's somewhere between 2 billion and 500 million cases of COVID-19 globally have been confirmed. Based on these numbers, tens of millions of people probably have lingering smell problems. So it is a significant issue. People can't smell and they may not recover that. 7% of those may not recover their smell. And for these people, help can't come soon enough. Simple activities such as tasting food or smelling flowers that we all take for granted are now not being experienced by a fraction of those who suffer this affliction. A clearer picture on how the virus causes this disruption can help us to create therapies. Now, understanding the biochemical methods helps us create drugs that can offset and overcome this. And early in the pandemic, a study showed that the virus attacks widely through all different parts of our body, most of our systems, but it specifically attacks cells in the nose called sustentacular cells. It's a mouthful, so I can't remember it, I can't say it. And these are the cells that provide nutrients and support to the odor sensing neurons in our nose. So they transport all the bits that keep the sensors in our nose, sense of smell going, they keep it alive and make it happen. And when they get disrupted, you lose sense of smell, and the virus blocks these cells. Since then, we've got more clues around what happens to these olfactory or the nose neurons after infection. Now, examination of people who have died from COVID-19, a bit morbid, but when you do an autopsy on these people, they found that their neurons are actually intact, but the receptors that are embedded within the membrane of the nose that detect odor molecules, they're decreased, and in some cases they never recover. And the architecture of these sensors in the membranes changes. And so you have a change in the biochemical structure of the membranes in your nose, which is caused by COVID.
So can I just say, before you go on, can I ask you, is what you're saying that the receptors that we use to smell, so the receivers in our bodies where the smell goes, they're in some instances being wiped out, or some of them are being wiped out?
They become restructured, so they're less effective. So the number of them decreases, but the way that they exist within our body and in the membranes in our nose, so we have mucous membranes lining our nose, and we have an olfactory nerve, which is where all these neurons send their signals, and the way that the structure of that changes in some people. In some people, they recover completely; it goes back. But if you have a really massive infection in the nose, you may not recover. That's one thing, that the physical morphology of the biochemistry of our nose and the physical representation of that, that's been observed. Other studies are suggesting that there's a genetic mutation in some people, and that's associated with a greater propensity for loss of taste or smell. So some of us have a mutation, and that also aids the virus in disrupting some of these things in our nose. Also evidence of lasting changes to the brain, some people with smell loss. So there was a study published earlier this year in March in the UK. They measured 780 odd people and had their brain scanned twice. And of these, about 400 people became infected with COVID-19 between the scans. So this study wasn't set up to be a COVID-19 study. It was a brain morphology study. But during the pandemic and the time between the sample taking for this study, half of the patients the people in the trial got COVID-19. So the researchers were able to directly observe structural changes in the brain in those 400 patients. And the survivors showed multiple changes, including markers of tissue damage in areas linked to the brain's olfactory center. So that's the link between the olfactory nerve and the brain. And it's not clear why this is the case, but one possibility is lack of input. So because we temporarily lose the ability to smell, our brains don't necessarily recover the ability to process the signals coming from the olfactory neurons, and the structure of the brain changes as a response to that. So it's the ultimate case of use it or lose it. You stop using your sense of smell because it doesn't exist, and the brain changes as a response. This is also observed with people who have accidents and they sever the olfactory nerve. So if you have a car accident, you bash your head on a dashboard, it's quite common. Those people will lose their sense of smell because the olfactory nerve is damaged or severed. And the similar changes can happen in the brain in that case.
So can I, just before you go on again, we're finding all this out about COVID and the long-term effects of COVID, do we have the same sort of long-term effects with influenza A, influenza B, potentially some of the other viruses, but we're not as aware of them because the studies haven't been as intense? Or are these long-term effects specific more to COVID? Like, again, I'm asking you for your opinion because I imagine there's not a whole lot of set research out about it yet, but it's interesting that COVID has all these ongoing effects that we're finding out about as time passes. And I'm wondering whether there's parallels in some of the other viruses.
Yeah, certainly there are lasting effects, post-viral complications with many viruses. Edema, emphysema, brain injuries, and influenza. And I think what we're seeing, this is my opinion, is that if we had the same knowledge of the way the body works in medicine now, if we had that 100 years ago with the flu pandemic in 1919, I think we would be able to make much more observations around the changes to our body and the longer term afflictions of the virus then. But over time, the flu virus has mutated. It's still a deadly virus for elderly people, but it's not killing 1 in 10 people like it did 100 years ago. And COVID-19 will evolve, similar. It evolves away from the parts that have longer term implications potentially. But people will get, chronic fatigue syndrome, post-viral infection from flu, rhinoviruses, other things, glandular fever. It's not limited to COVID-19. I think when you have a pandemic and large parts of the population get infected at once, more people are going to be complaining and making noise about these long-term side effects. Therefore, it becomes more of an issue.
It's absolutely fascinating watching this unfold with such a high interest in science, and watching the vaccines roll out, watching the disease morph into different variations, which brings me to, at the start of the pandemic, there was a lot of talk around treatment. So not just vaccination, but treatment for COVID-19. What's happening with all the research and the treatments at the moment?
Yeah, there's a fear that development of new treatments for COVID-19 could falter because the clinical trials needed to test them are becoming increasingly difficult to conduct. So as more people are being infected with COVID-19, as we've said before, we expect everyone will be infected at some point. Many of us have probably been infected and not realized we've been infected. But finding people who test serum negative to COVID infection to be eligible for clinical trials is becoming more and more difficult. And in many places, vaccines have led to a decline in severe disease, such as we've seen in Australia and throughout the Western world. We've got high vaccination rates, and that has shrunk the pool of potential study participants. There's also rising hesitance to enroll in clinical trials, and the existence of potential treatments is making the statistical analysis of the effectiveness of clinical trials much more difficult. So we've seen negative effects come from some vaccinations in trials. So we have hesitancy against vaccines, then hesitancy to volunteer for new clinical trials for new agents, new vaccines, and other things, not just limited to COVID-19, but across the board for all treatment areas. And we're also, the requirements for these drugs seems to be shrinking as more and more of us have been exposed to the virus or being vaccinated, and the severity of diseases seems to be decreasing. However, these factors don't override the need for new treatments, and current options for treatments such as monoclonal antibodies and other treatments such as these antiviral agents, I won't name them all because there's a few of them now, they're limited supply and they're still quite hard to come by. And the bigger challenge is that over time, some strains, emerging strains of COVID-19, if they have a high exposure to these antiviral treatments, they could become resistant. They could mutate and become resistant to those treatments. So we do need to continue to develop new drugs and new treatments for COVID-19. And there are a few different ways that this is occurring, through steroids that look at inflammation, antivirals that act on disrupting some of the bioreplication machinery of the virus, and some which work in such as platelet, plasma, and antibody infusion, which just swarm and create a massive immune response against the virus in our body. So a number of different approaches that are being taken, and we need to keep exploring these. And the risk is that we're getting complacent, we're learning to live with the virus. We're still seeing significant numbers of people dying each day, but I suspect that in the current flu pandemic, which has overtaken the COVID pandemic in some respects, there's most likely more people dying of the flu at the moment than COVID-19. But it doesn't negate the fact that we should still be developing treatments for all these diseases that are affecting your public health on such a massive scale.
Again, anecdotally, I've got a lot of acquaintances, friends, colleagues who have had the flu post-COVID, and the comment that I seem to be getting more and more of all the time is COVID had nothing on the flu. Is that because, are we more susceptible because immune systems are potentially lower because COVID may not be that far behind the people that have had COVID, and therefore the immune system isn't fully recovered? And I know, again, like I'm asking for your opinion because the research is probably not there yet. But would that make sense? Would it make sense that if you've had COVID and then a couple of weeks later, which seems to be kind of a pattern that I'm noticing anecdotally, that you might fall more severely to the flu? Or is it that the flu virus is more severe than or I guess it's all about a personal reaction to each virus, but what are your thoughts?
Yeah, I suspect that it's differing for everyone. And, I think most people who are having COVID-19 infections are moving past that now. So other viruses, as they come along, like the flu, if they're still in a fatigue scenario afterwards, the flu might hit them a lot harder. Again, that's just subjective. We're all different. We all work differently. There is a theory around that our immune systems get weaker when we're not exposed generally to a lot of pathogens. So normally our immune systems, the theory is that normally we're out playing in nature, we're outdoors, we're coming across lots of people, we're getting exposed to lots of different pathogens. We have bacteria that live naturally on us symbiotically, as we discussed last week. And what we have an immune response, our immune system lives symbiotically with these different environmental pathogens all the time. And it's called keeping the immune system primed, to theory. And it's saying that some experts are saying that now, because we've been basically locked in our sort of caves, we're back in our houses for the last 2 years, we're clearing away a lot of that natural flora on our bacterial load on our skin, with hand sanitizers all the time, where our bodies aren't as fairly primed, immune systems aren't as primed as normal, so that when we do get exposed to a pathogen like the flu, it hits us a lot harder before our immune system can kick up a gear and fight it off. So that's the other theory. Again, they're theories. I haven't seen solid research to support these theories one way or the other, but where there's a theory, there's usually some element of truth in the hypothesis or observations that led to that theory being established. So I think there will be more research that comes out that will shed light on this. But in terms of the circumstantial evidence, there certainly is a lot of people getting sick at the moment, which isn't good.
Yeah, and it kind of does, it pulls all the workplace recoveries back as well. But I think the thing that we are learning is that if we're sick, stay away from people and help everybody recover in that sense that we're not spreading things further. A final question for you. A word of wisdom for our listeners today. Do you have any words of wisdom to share? I mean, you've always got lots of words of wisdom, and we've just heard a whole string of wisdom from you. So thank you very much. But have you got anything to give us that final leave with today?
Yeah, so this one, I saw it as a sponsored tweet, I think, in my feed, and it was rather unusual, but it was from Peter Diamandis, the founder of Singularity University, and it was the difference between successful people and unsuccessful people is mostly mindset and how we approach and view the world. And mindset is something that we can work on and change. So I think if one word of wisdom, it is to explore how you can improve your mindset to be more optimistic than pessimistic, as that simply could be the difference between you being successful and unsuccessful in whatever it is the endeavor you're trying to undertake.
Thanks very much, because that was exactly, I read Peter's article, so I was actually going to go around mindset, but I am now going to go because you do need mindset for innovation and creativity. So it's very good that you started with that. So I read a quote recently that said, innovation is creativity with a job to do. And I can't exactly remember who said it, but it was innovation is creativity with a job to do. And I just went, oh, that makes so much sense. So it's that curiosity that leads to a creative response, and then it needs the innovation behind it in order to make it happen. And you live, breathe everything every day in your position as Director of Innovation at ANSTO. So I'm sure you can relate to that. Thank you for being with us today. Hopefully next week we'll have, or not hopefully, it's, it'll be a joy if we've got Mitra and we've got Simon back with us next week. Otherwise, very happy to spend another half hour sharing your wisdom and your knowledge with our listeners. So thank you for listening. If you enjoyed what you heard today, please share this episode with your colleagues and your friends, and join us next week. Tim, thanks a lot for being with us again.
Thanks, Christina, and thank you, audience.
Okay. Have a good week, everyone.